Okay, geometry. I am recording this. This is the last six problems of the review packet. So 45 on is all surface area volume of three-dimensional figures. Let's see if we can remember these formulas because I don't have them in front of me. Let's see. All right. On the test itself, you will only have one or the other, but not both, right? I won't have you do, and that should be area, by the way, surface area. All of these, typo is not my, or copy paste was not my friend, I guess. But I will only ask you for like surface area of a cylinder or volume of a cylinder, but not both of them, okay? So I'm just going to write the formulas down for surface area. Let's see if I can remember them. It is 2 pi r h plus 2 pi r squared. And then volume is pi r squared h, I think. Yes. Okay, so cylinder is pretty straightforward. Height is 12 because it's like laying down, and then the radius is 4. So 2 times pi times 4 times the height, which is 12, plus 2 times pi times 4 squared. And I'm going to do this. 2 times 4 is 8, and 8 times 12 is 96. Pi is what that is, plus you can type this all into your calculator if you want to. 4 squared is 16, and 16 times 2 is 32 pi, and 96 plus 32 is 128 pi, and now I just have to type in 128 times pi and call it good. 128 pi. Enter. That is 402.1 centimeters, and its surface area, so squared. Okay, then volume is a lot easier. Pi times 4 squared times the height is 12. This is 16. 16 times 12 times pi, and that is 603.2 centimeters cubed. Is it always true that volume is bigger than surface area? No, not always true. So, just so you know. In this case it is, but not always true. All right, now we have a cube, which is a rectangular prism. And surface area of a rectangular prism is capital PH plus 2 capital B. Volume is capital B times H, okay? Or, in this case, to find capital B, you're doing the area of the base, right? Which is like length times width times height. So you can think about it that way for a cube. Or this isn't a cube, actually. This is not a cube. This is just a rectangular prism because not all the dimensions are the same. So it looks like a cube, but it's not a cube. All right, let's talk about these things. Capital P is the perimeter of the base. So if I assume that the base is the bottom, the perimeter will be 12 plus 10 plus 12 plus 10, which is 44. 44, if I add those all together, okay, times the height, which is this 12, okay, so 44 times 12 plus 2 times capital B, and capital B is the area of the base, and this is the base, and the area of that is base times height, so 12 times 10 is 120, that's capital B, okay, all right, I'm just going to type that all in, 44 times 12 plus, this I guess is 240, 2 times 120 is 240. So 240, and I get 768, and that is in yards squared for surface area. Okay. All right. This one is capital B times H, which capital B was 120, times the height, which is 12, or you could do length times width times height. So 12 times 10 times 12. That's where we get the 120 from. And that is, I know that 12 times 12 is 144, but then I add a 0. So that, and that's in yards cubed. Okay? All right. It would not be a bad idea to make sure that you know how to type this stuff in, so be careful. Like, practice doing that, all right? This one is a pyramid, and surface area of a pyramid, I got to think here. I got to look this one up so that I can, like, make sure I don't do this wrong. Geometry chapter, what chapter do we want to do? Chapter 10. Nope. Here we go. Pyramid. Okay. Bleh. All right, yeah, I'm glad I looked this one up. Surface area is 1/2 capital PL plus capital B, and then volume is 1/3 capital BH. I remember that one because I know it's a third of what a prism is. So capital BH here, but 1/3 capital BH here. Okay, now we've got some slant heights and we got some regular heights. So we got to determine what that is. 7 is the slant height. So L is 7. Okay, now if I'm trying to find regular height, let's say like I'm like slicing into this thing right here, right? I'm slicing into this guy and here's my right angle. Like it's like that slice is coming like out toward us. Okay, this regular height is here. This length here on the bottom is 1/2 of 4, so this guy is 2. I don't know if you can like see that from the side. So let me flip him this way. Okay, so 7 is a slant height here, 2 is here, and then I want to find this, and that's going to be my regular height. So I'm going to do the Pythagorean theorem. 2 squared plus, let's call this guy x. X squared equals 7 squared. 2 squared is 4, so 4 plus x squared equals 49. And then let's subtract 4. So I get x squared equals 45, and the square root of that. They're going to start coming in from the next class. So I'm going to have to yell pretty soon. Okay, so regular height is 6.7. Okay, so let's start plugging stuff in. 1/2 capital P times L plus capital B. Okay, so capital P is the perimeter of the base. So it's all of these together added. And if all of them are 4, 4, 4, 4, 4, that's going to be 16. And then L we said was the slant height, that's 7. And then capital B is the area of the base, okay? And that is going to be 16, okay? So the perimeter of the base and the area of the base is coincidentally the same number, okay? All right, 1/2 of 16 is 8, and 8 times 7 is 56, and 56 plus 16 is 72 centimeters squared. Okay. Come in, have a seat, 8th period. I'm recording something really quick hey, shh. I'm recording something really quick, so have a seat and be quiet for a minute. Okay, this one.
Did you order a pep band shirt or no?
All right, capital B we said was 16. Hey, guys, did you hear what I just said?
Sorry.
Shush. Height is the 6.7 number. That's what we need for height. Okay, so I'm going to go 1/3 of 16 times 6.7 is 35.7, and that is in centimeters cubed. That's what he is. Okay, so that's for volume of that guy. All right, couple left. We've got surface area and volume of a cone. Okay, surface area and volume of a cone. This is pi RL plus pi r squared. I know is surface area of a cone. And let me make sure that that's true. Yes. And then whatever the volume of a cylinder is, a cone is 1/3 of that. So 1/3 pi r squared h is what we have. Okay. We got the same thing going on here as we did a prism. Ooh, this is hard. Is the 14 referring to like this side right here? Or is that the height here? Ugh. Let's go ahead and let's say that 14 is this slanted height here. I don't know. Let's go ahead and general consensus 14 is that slanted height there. So that means that we have to, if this is 5, we've got to figure out what capital H is. So slant height is 14. The radius is 5. We got to figure out what the regular height is. So we've got this going on. 14, 5. You might not agree that that's whatever, and that's totally fine. If that is questionable, I would hope that when the one on the test, I would actually do an arrow that shows you. But if it's questionable on the test, I will accept both answers. Okay, so because, I mean, you obviously did the problem correctly. You just used, your interpretation of what the numbers were was not the same thing as mine, and that's okay. So I will accept both answers if there's any question about it. All right, let's call this guy x. So 5 squared plus x squared equals 14 squared. 25 plus x squared equals 196. And if I subtract 25, this won't be a perfect one because 5 something 14 is not a thing. 196 minus 25, and that's 171. And if I take the square root of that, I get x equals 13.1. So that is my regular height. So regular h is 13.1. Okay, now I'm going to plop into some of my formulas. So pi times 5 times 14 is the slant height, plus pi times 5 squared. Yep. 5 times 14 is 70, so this would be 70 pi, plus 25 pi, which is 95 pi, because 70 and 25 added together are that. Or you can just type the whole thing in, but I would rather just type in 95 pi and do the rest in my head. 298.5 is what it will round to, and that is in meters squared. Meters squared, okay? 1/3 pi, radius is 5. The height is that 13.1 that we figured out, okay? And because there's a decimal, I'm going to type some of this into my calculator. So 1/3 times pi times 25 times 13.1. Okay, and I get 342.95, so 343.0, and that is in meters cubed. Meters cubed. Okay. All right, you algebra kids, I have 2 problems left for this recording. If you have not yet watched the first 12 questions from the review, I'm going to play that up here in just a minute. So wrap up what it is you're doing, get your reviews out. I'm going to play that here in just a second as soon as we're done, as soon as I'm done recording this, okay? All right, surface area volume of a cube, or of a sphere, 4 pi r squared and 4/3 pi radius cubed. And all I need to do is my radius is 5. So 4 times pi times 5 squared. 5 squared is 25, and 25 times 4 is 100. So all I need to do is take 100 times pi, and it's like that 3.14, but with a decimal moved, so 314.2 is what it will be. Meters squared again for surface area. Okay, volume is 4/3 pi times 5 cubed. Now 5 cubed is 125, okay? I don't know how you guys do it in your calculator. If you have one of those, and a couple of you do, have one of those fancy calculators that has like a button that like has like one of these, you know what I'm talking about? If you have a button that looks like that on your calculator and you can type in 4/3, that makes it really fancy. But if you don't, how I would type this in, I kind of type this in backwards. I go 125 times pi times 4 divided by 3. That's how I do that. Whatever. Doesn't matter. You do you. Times pi times 4 divided by 3. And I got for volume 523.6, and that is in meters cubed. Okay? All right, last one. Surface area of a hemisphere. Okay, and a hemisphere is like a half a sphere, right? So it looks like this, and the radius is 8. Now, I put this on here for a reason, and the reason why I put it on here was that surface area of a normal sphere, like a whole sphere, like this whole thing, is 4 pi r squared. But if I'm doing a hemisphere, I'm like cutting it in half, right? Okay, so if I divide that by 2, I get 2 pi r squared, right? Like that would be the surface area of the half sphere. But the problem is surface area is area of all of the surfaces. So if I cut the sphere in half, I now have a surface exposed, and it's like this bottom surface, right? So I have to add on to that the bottom surface, which is another circle, right? And the area of a circle is another pi r squared, okay? So now that I've cut it in half, I have another surface that I have to add to that, which is another pi r squared. So now I have 2 pi r squared plus another pi r squared, or like 1 pi r squared, so 3 pi r squared. So surface area of a hemisphere, I'm going to say hemisphere, is actually 3 pi r squared and not 2 pi r squared. So that's all we have to do. We just plug in our 8 for our radius, and 8 squared is 64, and 3 times 64, if you want to do that, is 192, I believe. And you take I'm going to check that, 64 times 3 is 192, and I'm going to take that times pi. and I get 603.2. I think that was an answer up here, maybe. Yeah, 603.2. What? Anyway, whatever. Yards, and that is surface area, so yards squared. Okay? All right, so wouldn't be a bad idea to practice typing those in. Again, on the test, you will not have surface area and volume. You will only have one or the other, right? But make sure you have all the formulas written down because you don't know which one I'm going to ask. So your test should actually go a lot faster than what this review was. Make sure that you have all of this written down for, let's see, geometry first period and fifth period is Monday. Make sure you have this whole packet filled in for Monday. If you do not, go back and find the video that you need. They should be posted on Google Classroom except for like day 2 because I think everybody was here day 2. And maybe my recording didn't save. I don't remember. Anyway, so should have everything else. No, I think day 2 is even up there. I don't know. Make sure you have everything written down. Okay? All right? And know how to do all of it. All right? If you don't, ask me. All right, goodbye.